Math 2, Unit 13, Section 3. Today we're going to talk about independent and dependent events. Independent events are when the occurrence of one event has no effect on the occurrence of another event. So, can anyone think of something that may be an independent event? Okay, what do you think, Alyssa? If you're just drawing one card, true. And then if you drew a card from a deck of cards and then put it back in, that would also be independent. Because it wouldn't matter what you drew the first time, you could draw it again if you put it back in the deck. Another thing that would be independent events would be like rolling a die. Because I could roll a die and get a 3, and the next time I roll it, I could still get a 3 again, right? And so those are independent events. It doesn't matter what you get the first time, it doesn't change the outcome. Dependent events are basically the opposite of that, and that is that depending on what happens with your first probability, it changes the outcome of the second. And so the cards are actually a good example for a dependent event, because if you have a deck of cards and you draw a card out and you keep it, that's going to affect the next card you get because you can't get the cards you already have. Does that make sense? So, for instance, I'm dealing cards, okay? Let's say you're trying to get 4 of a kind, okay? Well, I give you an ace and you get an ace. Well, can you get 4 of a kind now with aces? No, because Natalie has an ace and you have an ace. So there's no way you can get 4 of that card. So depending on who has dealt what cards changes the outcome of everything else, because there aren't more than 4 aces in a deck of cards. Okay? When you're dealing with dependent events, this formula you need to remember. Anytime you see and, this is dealing with multiplication. Also, you are multiplying the 2 events. This is once the event has happened. So you're multiplying the probability of A, and then you're multiplying by the probability of B once A has happened. So you have to take out the A part that's already happened. We're going to start with a couple independent event examples. So it says you're tossing 2 coins. You have a nickel and a quarter, okay? 2 coins. The nickel is flipped first and lands on tails. The quarter is flipped second. The outcome of the nickel, heads or tails, has no effect on the outcome of flipping of the quarter. Do you guys all agree? Okay, so what is the probability of both coins being tails? So, how many tails are there on a nickel? 1 out of how many possible choices? 2. And then we're doing, it's saying, and both of the things happening, how many tails are there on a quarter? 1 out of how many possible outcomes? 2. Okay, when you're multiplying with fractions, anything on the top can reduce with anything on the bottom. But in this case, there's nothing to reduce, so you multiply straight across. So 1 times 1 equals 1, and 2 times 2 is 4. So the probability of flipping the coin and getting a tails on both of them is 1/4 probability. Okay, number 2. A spinner with 4 equal sections, A, B, C, and D, is spun and a coin is flipped. The outcome of the spinner has no bearing on the outcome of the coin being flipped. Therefore, the events are independent. What is the probability of spinning an A and flipping a tail? So I'm going to give you a minute to try to figure that one out. You got it? Okay, give me a thumbs up if you think you have the answer. Okay, so how many A's are there on the spinner? 1 out of how many total? 4 times, and then how many tails are there? 1 out of 2. Nothing can reduce, and you get 1 out of 8. Any questions? Okay. All right, so these we're dealing with independent events. Now we're going to talk about some dependent events. Okay, so this dependent event, they're telling you that an ice chest contains 10 cans of soda. 3 cans are grape, and 7 cans are orange. First question says, what's the probability of picking a grape soda, drinking it, and then picking an orange soda? Okay, so first of all, how many grape sodas are there?
30.
Out of how many total? 10. Okay, so the grape soda, you've taken one of the grape sodas out. Okay, so now what's the next probability? How many orange sodas are there? No, there's 7 out of how many? 9. Because you took out a grape soda, so that one is gone. So one of the grapes, that means your total has gone down by 1, but all the orange ones are still there. Does that make sense? Okay, now can anything reduce here? What can reduce? Good. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Do we see anything else that can reduce? And so on the top, 1 times 7 is 7, and 10 times 3 is 30. So that's the probability of first getting a grape and then getting an orange. Okay, number 4. It says, what's the probability of the second can being an orange soda if the first can was an orange soda? So they're not wanting us to do both of the events together. They only want the second event. So if an orange can has already been taken out, what's the probability of getting another orange? How many oranges would be left? 6 out of how many total? 9, because this is a new problem, okay? So we go back to having a total of 10 cans. They're taking out 1 orange, so instead of 7, there's 6, and the total went from 10 to 9. Can that reduce? Good. We can divide by 3 to the top and the bottom, and so we get 2 over 3. Okay. What's the probability of picking 2 orange sodas in a row? So this one, they're asking, what's the probability of getting an orange soda and then getting another one, and you multiply them together. So I'm going to give you a minute to try this one on your own. Okay, what's the probability of the first orange soda? How many orange sodas to start with are there? 7 out of how many? 10. Okay, we take out 1 orange soda. How many orange sodas are now left? 6 out of how many? 9. Now, we can reduce anything on the top with anything on the bottom. Can anything reduce first right now? Okay, 6 and 9? 6 and 10. Okay, we can do it that way. So when we divide these, we divide them each by 2. So this becomes a 3, and this becomes 5. I can reduce this again. So do you guys see how 3 and 9 can reduce as well?
Yep.
So 3 divided by 3 makes this a 1, and 3 goes into 9 3 times. So you should end up with 7 over 15. How many of you got it right? Good. Okay, any questions? All right.